Welcome to Getting to Know Google SecOps. I'm John Stoner, and today we're going to introduce a string function that counts the number of substrings within a field. This function can be used as you build searches and rules in Google SecOps. Strings.countSubstrings quite simply counts the number of substrings within a specified field or variable using the pattern provided. The result is an integer output value. The syntax requires two arguments: the field or variable that needs to be observed, followed by the pattern that is being matched, which should be enclosed in double quotes. This function can be used in a search or rule to narrow the data set by placing it in the filtering statement of a search or in the event section of a rule, or it can be used in the outcome section to calculate a statistical function based on the integer output. One example use case for counting substrings is to focus on command switches that may be used by an adversary when multiple commands are being stitched together into a single process launch, and using this to identify anomalous activity. Let's take a look at an example. Let's start with this simple example in search. We've been told that a web page named contact.aspx is suspicious, and there is some concern that it is associated with a web shell. We could search target.process.command-line to see if it's referenced. Alternatively, we could use the function strings.count_substring and look for the pattern contact.aspx and return all events where the number of substrings is greater than 0. Let's start by doing that. We can see that there are a few rows returned that reference this pattern one or more times. That said, this might not be the best use of this function, since we could probably write a faster search by just specifying the string we want to match and not add the additional aggregation step that goes along with the count. Looking for more than one instance of the string in the command line would be a better use of this function, which is what we're doing now. In our results, notice we can see contact.aspx referenced more than once as the command line appears to have multiple commands ANDed together. Also take note that we used a function called strings2lower that addresses case sensitivity, and in case this is turned on in the search, we can still match for all lowercase patterns against the command line. Let's remove our line of criteria from the filtering statement and use it in a statistical search. This time we can aggregate our process launch events by the hostname variable, which is principal.hostname, and in the outcome section, we're going to count the substrings again for contact.aspx, but this time we're going to output the maximum value, the sum of the substrings, and the command line values that contain contact.aspx. In our results, we can see that work-pacman had a max value of 2. Which means that in the command line field, contact.aspx was referenced at most twice. The second value, the sum, is adding up all of the times contact.aspx was referenced in the command line field based on the aggregation of the principal host name and the search time window. Finally, we captured the command lines that contained contacts.aspx for reference as well. Based on this, our next step would likely be to dig into the pacman host for additional investigation. Because we can also use strings.countSubstring in rules, let's take a look at what that might look like. We're going to leverage the concepts that we applied in search, but this time we're going to count a different substring. The string 2 greater than and 1 may be seen in command lines. Adversaries may use this to redirect standard error to the same destination as standard out, which makes error messages generated by commands get combined with standard out while potentially maintaining stealth. Because it is a common technique, we're going to build a detection that triggers when the number of these substrings exceed a defined threshold within our aggregation window. Our rule looks a good deal like our search. The main change is that instead of searching for the pattern of contact.aspx, we're now looking for 2 greater than and 1. In our rule, we are aggregating by the principal.hostname over a 5-minute window, and in our conditions section, we're expecting more than 15 references in the command line in that 5-minute window to trigger our detection. When we test our rule, we get a detection with a number of events. The benefit of using sum here is that we can put greater weight to the frequency of the value seen rather than the number of events it was in. We can also see the command line values that contain this string to better determine our next steps in our hunt or investigation. The strings.count substrings function provides us the ability to generate an integer value based on the number of substrings found within a string based on the provided pattern, and then apply additional criteria to this value. The syntax requires both the field or the variable as well as the pattern enclosed in quotes. Depending where the function is used, it may require an aggregation function like max or sum to be prepended to it along with an outcome variable, or it could be used in the condition section of a rule as a threshold value. This function can be used in the filtering statement of a search as well, in the event section of a rule, as well as the outcome section. It just depends if this value is designed to filter out data or is part of a computation. If you want to learn more about Google SecOps, check out my blog series called New to Google SecOps for more handy tips. We have a number of community YARA-L detections at our GitHub site and are continually adding more. And don't forget to engage the security community at secopscommunity.com.